All right, this is going to be a relatively quick one today. I received a question on a lot of anti-aging compounds that are being investigated, being discussed, or really making their way around blogs. The main one was rapamycin, but I know metformin and a few others have been mentioned. So what I want to do is just try to give a quick overview of the mechanism that is being proposed as to why you would take any of these compounds, what the potential side effects are, and are these, really potentially anti-aging miracle drugs, or are they all hype? So, without any further ado, one of the main things to understand first is what exactly these drugs appear to be targeting. Now, rapamycin may be familiar to some folks because, well, it is the mTOR pathway or mTOR complex gets its name. mTOR is the mammalian target of rapamycin. Basically, this thing is inhibited, actually, not activated by rapamycin, but mTOR, as we know, is the uh, somewhat debatably a central switch or central hub for various anabolic processes in the cell. Protein synthesis, cell growth, etc., has an effect on immune function, fat storage, and aging. Most folks here may know the mTOR pathway as being the one that we say, operates at cross purposes to the AMP kinase pathway. It is the master switch for muscle growth, et cetera, et cetera. Of course, it's not actually that simple. mTOR itself is, often its activation is often associated with, for example, muscle growth, but there are certain factors for muscle growth that don't seem to cause much mTOR activation slash stimulation at all. And there's plenty of evidence that mTOR can be activated in decidedly non-anabolic situations. So it's important to keep that in mind. Um, it's found in two complexes now. There's mTORC1 and mTORC2. I don't want to really get into the details of each because they're extremely complex mechanisms, and I think that's something we need to come back to again and again. mTOR itself, this particular protein, these complexes are associated with so many processes in the body. We can't even really begin to articulate them. Even just listing them out by name would probably consume several hours of lecture time. But what does this have to do with aging? Why aging? And what's really interesting is that animal studies at all ages across multiple species have shown that inhibition of this particular complex extends life. Now, since rapamycin, which binds to this other FKBP12 molecule, inhibits mTOR, you would think that therefore rapamycin, when administered, would inhibit this particular complex and extend life. Now, what is rapamycin? It is so named because it was initially isolated on Easter Island, hence where the rapa comes from bacteria. People who found the compound noticed that it inhibited yeast growth without any real impact on the bacteria whatsoever. Now, it was initially found, as it says here, inhibit the immune response, so it's actually been used as a quote-unquote immunosuppressant to help especially with things like, not rejecting skin grafts, and other transplant rejection. It's also investigated as anti-cancer therapy. Now, a few people who especially advocate for the use of rapamycin find this unfortunate because it's been given the label of immunosuppressant. I think there's a lot of fear associated with the compound itself and the idea that administering rapamycin causes, clinical immunosuppression to the point where you would be very prone to illness, disease, etc., etc. Now, also, besides rapamycin, there are compounds out there called rapalogs, or rapamycin analogs. These are, in many cases, pharmaceutically developed, and they are attempts to create more specific compounds that target more specific receptors, specifically maybe just mTORC1 as opposed to mTORC2. And the idea is that there would be fewer side effects, and these would have more use in preventing cancer growth and overgrowth. Now, bear in mind, since the whole mTOR complexes can be kind of a master switch for anabolism and cell growth and division, etc., slowing them down actually slows down proliferation, tumor proliferation, and a number of different cancer lines. All right, anyway, all that's very interesting and all, but how and why does this work? Well, there are a couple possible mechanisms of action as to why rapamycin and inhibition of this complex could slow aging. Now, the first thing we want to talk about is decreasing rate of translation. If you think about the process of protein translation in your body, and you think about the fact that every time a protein is created, there is essentially error-correcting mechanisms that go on. The body basically proofreads it. Faster translation, there's only a certain number of error-correcting enzymes, a certain rate at which it can take place. Faster translation is potentially, well, not potentially, it is associated with a higher rate of errors. if you look at a lot of age-related illnesses, accumulation of perhaps improperly folded proteins can actually be a major cause of, or a exacerbating factor in age-related illness. If you're slowing down the rate of translation, what you can get is, as it says here, greater fidelity during synthesis, reduced load on error correction systems. Now, this is questionable. There's studies back and forth that show that even in certain species where translation would be unaffected potentially, by mTOR, it's still the application of rapamycin still seems to reduce the aging-related side effects. It could be that there are certain kinds of RNA and certain kinds of protein that are affected by this, others that are not, etc. So anyway, that's one theory. Another one is increased autophagy. Now, autophagy slows with age. And if you think about it, the cell cleanup, the cell self-cleanup and destruction of busted organelles, that is a very highly scientific term, effectively cleaning out bad proteins, cleaning out bad structures, etc. This is something that takes place at a much greater rate when you're younger. As you get older, a lot of these cells start to accumulate. Again, you have dead or dying or ineffective cells and organelles that aren't functioning properly, and the lack of self-cleaning can actually, again, be one of the factors in age-related illness. So mTOR itself inhibits autophagy, so inhibiting mTOR, therefore, would induce or allow this to take place at a greater rate. Also, anti-inflammatory mechanism. Now, we talk about an anti-inflammatory, and in fact, a lot of immune responses associated with inflammation. Many people, many advocates for rapamycin have said it's not an immunosuppressant. What it is a hyperimmune response attenuation drug, which is really just another way of saying immunosuppression, but basically saying what it's doing is stopping a hyperinflammatory, hyper-strong reaction, not really suppressing your immune function below baseline, but really just saying, okay, well, this particular compound can reduce the inflammatory response and reduce the immune response down to normal levels. As we know, runaway inflammation is associated with a lot of, again, age-related illness, a lot of illnesses, illness progression in many cases. So anything that reduces systemic inflammation, again, may potentially be beneficial for long life. Now, acute usage of the drug actually improves your insulin sensitivity. However, chronic usage reduces your insulin sensitivity. Now, that's not necessarily a bad thing. If you're familiar with something called starvation diabetes, effectively, if you're starving, if you're not eating for an extended period of time, you will actually show a reduction in insulin sensitivity. This is an adaptation just to lower calories, to lower presence of glucose, et cetera, et cetera. So that may not be a bad thing. But anyway, important to bear in mind that insulin sensitivity and the effect on insulin sensitivity here may, again, have something to do with the progression of certain long-term illnesses. Another one that's still under investigation. It seems to be that mTOR itself has an impact on stem cell function, and somehow rapamycin, in inhibiting the mTOR complex, actually aids the body in retaining and or producing more what you call pluripotent stem cells. The exact mechanism by which this takes place, we don't know, but it's certainly a phenomenon that's been observed, and whether or not this, again, plays a role in kind of maintaining health and vigor, especially as you get older, a greater pool of stem cells to pull from, remains to be seen. The last one, inhibiting mTOR actually delays and or reverses cellular senescence. Now, that is an interesting concept. A cell, an active, healthy cell in the human body, can effectively divide only so many times. As long as it's given a growth stimulus, the cell will, carry out all the processes necessary for it to, carry out its life functions. And in many cases, then they die. Blood cells, et cetera, have a given lifespan. If a cell is no longer dividing it, but is still being given a growth stimulus, in other words, if the cell is growing but has nothing to do, what happens then when the cell, for example, telomeres, shorten and shorten and shorten, and you accumulate DNA damage, etc., and the cell is no longer dividing? What you get is something called cellular senescence. Senescent cells do play an important role in certain functions in the body. They're not always bad, but overall cellular senescence, induction of cellular senescence via various gene deletions and clinical experiments show that greatly increases drastically truncates the lifespan of experimental animals, suggesting that anything that slows cellular senescence, which may very well be simply slowing growth, so that in older individuals, you're slowing down the process of cell growth and cell division, Anything that would do that would therefore reduce the rate of cellular senescence. You'll say, well, then of course you will live longer. Your cells are not being told to continue to grow and divide and then age and reach this senescent point, especially because there's no reason for them to. So the overall conclusion here, as you can see, multiple mechanisms, some are uncertain, all are under investigation, but it seems to be that there are multiple ways by which this particular compound and inhibition of this particular complex could potentially extend life. And in fact, in a lot of lab experiments with a multiple different animal species, it does seem to do so. So that sounds great and all. Why would you not take it though? I mean, there's no free lunch. Well, there is a lot of debate on the incidence of side effects. Now, of course, immunosuppression concerns. Certainly it's one of the indications for individuals who are taking the compound is, you may have a higher incidence of viral bacterial infections. One interesting thing to mention, though, is that this drug, rapamycin, is primarily given and investigated. The way clinical trials work is if a drug is being investigated, it's being investigated for a specific purpose. In this case, rapamycin, since it was primarily purposed for both cancer trials and for, say, organ or skin transplant, these are generally sick patients. These are generally sick and immunocompromised patients already. So the introduction of something like, any sort of immunosuppressant may in fact return slightly higher rates of secondary infections regardless. So that's something to keep in mind. That doesn't mean that rapamycin may not cause a higher incidence of viral or bacterial infection in healthy individuals, but it's just something to keep in mind when you talk about a high incidence of side effect in a very sick population already. That being said, there's still the potential that the immunosuppressant properties of rapamycin may, in fact, mean you are more prone to other illnesses. Another one, hair and nail disorders. Alopecia arrives in up to 90% of patients. And of course, this makes sense if you think about the fact that hair growth is very much a constant anabolic process, large amounts of protein being generated. And if you do anything to slow down the rate of protein synthesis or the rate of new tissue generation, you will stop growing hair, for example. Another important one, loss of testicular function and a reduction in male fertility. This one is notable because the previous two items both seem to be dose dependent. Chronic extended higher dose usage leads to a high incidence of those previous two side effects, whereas acute administration or intermittent lower dose administration does not. With loss of testicular function and reduction in fertility, that appears to be a side effect almost no matter what level of drug is taken or how common or how often you take it. That is pretty crucial. And again, this makes sense. It would be an anabolic process. So, of course, anything that would reduce the rate of cellular generation, proliferation, etc., which is very much sperm production is rapid runaway cell growth. It makes sense. Of course, we mentioned glucose intolerance and insulin resistance, and we talked a little bit about that already. And the last point would be potentially less lean mass retention as you age. Again, mTOR is responsible for, or at least plays a somewhat central role in muscle growth. We know we can still simulate muscle growth without necessarily activating the complex, but it would stand to reason that a complex that is so centrally located in cell anabolism would still, potentially inhibiting this would still reduce the amount of lean mass you could build or maintain as you get older. Now, again, it is important to note this is dose dependent. Low dose and intermittent usage seems to have a much lower incidence of side effects. And it does still seem to have a statistically significant impact on lifespan. Not as great an impact on lifespan in certain animal models where the chronic higher usage will result in 24% longer life. A more intermittent dosage would result in about a 10% increase. Now, would these numbers bear out for humans? Impossible to tell. It is also important to note that the Rapalogs are disappointing so far. Rapalogs, again, are different rapamycin-like compounds that a lot of pharmaceuticals are developing with the goal of having more targeted approaches to fighting cancer. Again, the side effects with rapamycin, especially in high doses, may be considered unacceptable to some. So they're saying, let's see if we can develop compounds that will preferentially only inhibit mTOR1. The problem is these seem to have very minimal impact on less effective for anti-cancer and minimal impact on anti-aging. That's because the two mTOR complexes actually do relate to each other quite a bit. And in fact, inhibiting one complex may still leave certain pathways intact that may be responsible for cancer growth, cell division, et cetera, et cetera. So there are almost no Rapalogs out there so far that seem to be remotely effective for anti-aging. There's some that have very selective potential benefits and some potential positive data in certain animals, but for the most part, if it says Rapalog, it's snake oil. Anyway, the overall conclusion, intermittent administration later in life may be safe and effective. And there's a reason I say later in life, but I'll get back to that in a second. One other point that was brought up besides rapamycin was, well, what about metformin? Now, metformin only comes in here because some people suggest, well, how about you take it in conjunction with rapamycin? That may aid in some of the insulin resistance related side effects, etc. What does metformin do? Well, we know it's prescribed for type 2 diabetes. One of the interesting things it does, of course, is via activation of AMP kinase, it therefore inhibits mTORC1. Now, we know that, of course, AMP kinase, which is a pathway that many fitness professionals may associate with endurance exercise, responsible for mitochondrial proliferation, et cetera, et cetera. Activation of that pathway inhibits the mTOR pathway, specifically mTORC1. Now, metformin, therefore, it has multiple benefits besides just activation of this pathway in controlling food intake, controlling body weight. It's beneficial for pre-diabetics, reduces incidence of certain common diseases, age-related diseases. Now, most of metformin's investigation have been on patients with type 2 diabetes or pre-diabetic patients, and it does indeed seem to decrease all-cause mortality in these patients and therefore extend life. The only critical thing to keep in mind there, though, is that prediabetes and type 2 diabetes and diabetes in general increases all-cause mortality pretty much across the board. Any issue with glucose regulation, insulin sensitivity, etc., has multiple negative effects on multiple different pathways. So metformin being able to reduce all-cause mortality in pre-diabetic or type 2 diabetics would stand to reason. It would make sense. If you have a disease that increases all-cause mortality, if you address that disease, you decrease all-cause mortality. Now, there is not much evidence whatsoever that in healthy non-diabetic patients, chronic metformin administration does anything to increase lifespan or decrease all-cause mortality. There are actually several trials that are investigating that at the moment, though, so I may have to change my tune on this. Drawbacks, of course. Well, most interesting drawback of metformin, potential attenuation of exercise-related adaptations to muscle growth and the exercise-related increase in insulin sensitivity. In fact, certain studies have shown a even clinically significant reduction in aerobic capacity when individuals are put on a training program with metformin versus without. That means it may be reducing potentially some of the positive effects of your exercise. So if you are a runner, you're an endurance athlete, or really, exercise and training is a big part of your life, metformin may reduce the effectiveness of it. That is very important to keep in mind because it seems to be that if you are already engaged, you already have a healthy diet, you are not a type 2 diabetic or you are not pre-diabetic and you're engaged in regular exercise, it seems unlikely that not only will metformin benefit you, but it may even be likely that it is of net detriment. Also, it seems to cause a reduction in B12 and B6 absorption. It's recommended that you supplement with it, with those two B vitamins if you take it. And of course, again, conflicting information results in multiple animal models. Conclusion there, nothing compelling. Trials are ongoing. Preventative evidence is weak. I don't really suggest metformin as any sort of anti-aging drug. It may have more interesting properties down the line, but overall, when you look at the results, there is a lot of hand-waving. There's a lot of theories. There are a lot of, I found a whole bunch of opinion pieces that kind of try to extrapolate from animal models and studies done in pre-diabetics or type 2 diabetics and try to extrapolate that to healthy individuals, but nothing that directly shows much anti-aging benefit whatsoever in healthy individuals. So I would say give that one a miss. So overall, well, the data is promising for rapamycin. And full disclosure, I went into this whole segment here obviously being familiar with the compound, but being somewhat negatively predisposed to it. But I think in a review of the literature, while I don't suggest that everyone go out and start taking rapamycin or that it's a miracle drug as it stands, I think it's a very interesting area of research. My overall understanding and kind of looking at the research, what I would say as well is later in life administration, particularly when you're after 40, you're not planning on having children or anything else, and you lead otherwise a healthy lifestyle, it would seem that lower dose intermittent administration is not necessarily a bad thing. Now, as it says down there, I cannot make any evidence-based recommendations on dosing, but I will say that it appears to be relatively low in side effects and may indeed have positive benefits. Again, this is not a recommendation to go out and start taking rapamycin, but it's also me saying that there's enough interesting evidence here that it's frankly potentially a benefit. Now, Rapalogs, again, avoid them. Anything that says natural Rapalog is advertising itself on various websites or anything else, ignore. Again, anything outside rapamycin just doesn't seem anything that claims to have a lower incidence of side effects or be natural. Rapamycin itself is natural; it comes from a bacteria. Anything else claiming a lower incidence of side effects may very well have no positive impact whatsoever. So, rapamycin also works significantly better in conjunction with regular exercise, even potentially caloric restriction, and overall a healthy lifestyle. So, as an additional component, if you are over 40 or over 45 and already engaged in a relatively healthy lifestyle, it would seem to be that if you decided to investigate potentially using rapamycin as something to reduce a lot of age-related illnesses, you could certainly do a lot worse. And that's about the highest praise I think I've given anything on here in a while. So there you go. Hope this was interesting. Thanks for listening.